Oh, hello. This is the third example for using LIFEREG. And again, this is a demonstration to show how to use LIFEREG for arbitrarily censored data. And in particular, we want to show how to plot predicted probabilities against fixed levels of a categorical variable, and even if this is an interaction. Okay, so basically we're going to use the XDATA equal to option in the LIFEREG. First, let's ready in a artificial data set called a natural discovery. You get the variable sex, age, and time 1, time 2. So that's the using the two variable to code different censoring time. Read them in, and so we have 20 mice. Sex is gender of the mouse. Age is age at the injection. Time 1, the first time for measurement for recovery. Time 2, second time of measurement for recovery. If the mouse was recovered at time 1, then time 1 equal to missing, and time 2 equal to time of the first time, first measurement. So this is the left censoring case. If mouse was not recovered at time 1 but recovered at time 2, then time 1 equal to the time of first measurement, time 2 equal to time of second measurement. This is just interval censoring. If the mouse was not recovered at time 1 and not recovered at time 2, then time 1 equal to time of second measurement, time 2 equal to missing, so right censoring. So we have all the types of censoring in the data set. So now here is we need to prepare for the XDATA option in the LIFEREG. So we define another rows of data. One is called X row 1, and then the other one is X row 2. Okay, you can call proc print to print out X row 1, X 2 to see what's in there. So here is we use ODS graphics on and call LIFEREG data equal to mice. This is the key. The XDATA equal to X raw 1. Then classical sex, and we model time 1, time 2, age, sex, and age by sex. Distributions of Weibull, and we call the probability plot, and we say p low equal to 0.5. Virtual reference intersection is 75, and virtual the label is 75%, and use the inset statement here and run. Then the ODS graphics off. Okay, so if you take a look at the LIFEREG documentation, you can see the XDATA equal to SAS dataset specifies in input SAS dataset contains values for all the independent variable in the model statement and variables in the class statement for probability plotting. If they are covariance specified in the model statement and a probability plot is requested with a plot statement, you specify fixed values for the effect in the model statement with the XDATA equal to dataset option. And there's a hyperlinked detailed description of the contents of the XDATA dataset. So if you have time, please do check this out. Okay, so it's here. There's more information about how to use XDATA equal to dataset option. Okay, so let's take a look to run these ODS graphics. That may take a while. Okay, now we got the model fit, and also we got the probability plot. Okay, so this is the probability plot. Tells you there's 9 uncensored case, 5 right censored case, 2 left censored, and 4 interval censored. This is the Weibull distribution. The shape parameter to 0.447, and so this is the probability plot, the time 1, and the percent. Okay, and you have a confidence band around it. Okay, and similarly we can do another graph, but now look here, XDATA equal to X row 2. So we're using this row, X row 2. So we get data line, you get a 260.6. Okay, so if we run this chunk of SAS code, and we see the Weibull probability plot in this case. So remember, this is this corresponds to the X row 2. So it is different compared to the time 1, the X row 1 here. Okay. So by using this XDATA tool, you can really look at the different levels. You can plot the probability plot at different levels of a covariate value.